In this video, we are programming the Greatest Common Divisor, or GCD, in 13 programming languages at once. First of all, what is GCD? The GCD is the greatest positive integer that divides two integers. Take, for example, 54 and 24. Now, for 54, here are the integers that divides 54. And for 24, here are the integers that divides 24. Now, as we can see, the number 6 is the largest number that divides both numbers. So the GCD of 54 and 24 is 6. Now, why is GCD useful? One use of GCD is to reduce or simplify fractions. So for example, if we take A divided by B, we can compute the GCD of A and B and divide both A and B by GCD to get the simplified fraction. For example, if we take 42 over 56, we can take the GCD of those numbers, which is 14. Then we divide both the numerator and the denominator by 14 to get 3/4, which is a simplified fraction. Another use of GCD, or another place where GCD is useful, is after having performed the 4 classic arithmetic operations on fractions. For example, here we have the formula for addition. Here's the formula for multiplication. Here's the formula for subtraction. And here's the formula for division. Now, if we take this example here of an addition, 1/6 plus 7/15, we can see the result over here if we just use the formula directly. If we take the GCD of 57 and 90, we get 3, which means that we can simplify the fraction by dividing both the numerator and the denominator by 3 to get 19/30. Now, how do we compute the GCD? We compute the GCD using Euclid's algorithm. Now, this is one of the oldest algorithms in common use. It was presented by Euclid in his book Elements, published 300 BC, book 7, propositions 1 to 2. The code I'm going to show you uses only those constructs that are found in the 13 languages you see over here. So this is how we can program in 13 languages at once. So let's start with the first line of code here. Now, GCD, or Greatest Common Divisor, is a function that takes two numbers, A and B, and produce another number, the GCD. First, we need a variable called t, which is also a number. Now, the algorithm consists of a loop. The loop continues until b is equal to 0. So we continue looping as long as b is not equal to 0. The first step inside is to set t equal to b. The next step is to set b equal to a mod b, or modulus. And the third line here is to set a equals to t. Now, when this loop is done, the result, the GCD, is in A, so we return A down here. Now, if you want to know why this algorithm works, you can check out the link on the last slide. Now, let us look a little closer at this implementation. So here, the example I showed was written in TypeScript. And here we see the same code as we saw on the slide. We can look at the same code in Java. Now you can see in Java, declaring a function is a bit different. We use the public static instead of a function. And we have the return type here instead of behind. Now in Java, the number type we use is double. And the loop is almost the same as in the TypeScript example. Now, of course, you could use integers here instead. The C version is very similar to the Java version. The only difference is that we use the fmod function to produce the modulus of the two numbers instead. The C++ version is the same as for C. The JavaScript version is the same as the TypeScript version, except for the type annotations on the variables. The C# version is very similar to the Java version. The PHP version also do not have the type annotations, and the variables are now prefixed with a $sign. Except for that, the implementation is very similar. In Python, we have no type annotations, and we don't even need to declare the variable. The loop has now turned into a while loop, but except from that, the implementation is very similar. In Visual Basic, the implementation is a little different. Here we have a while loop, and the not equals to is this sign instead. And the mod operator is a mod infix operator. In Swift, we need to use the truncating reminder function to produce the modulus of two floating point numbers. The LibreOffice Basic is very similar to Visual Basic. The Ruby function is very similar to the Python function. And the Visual Basic for Application version is very similar to the Visual Basic version. So those were the 13 languages. Let's now try it out over here on the examples we viewed earlier. So for example, 19 and 30, 13, 30. I mean 57 and 90. We can see that the GCD is 3. Now for this example here, 42 and 56. We see that the GCD is 14. Now, if you want to check out the implementation on this page, I will show the link below. Now, here are a few of recommended resources. The 2 Wikipedia articles are good for learning more about the algorithm. And the link down here explains why this algorithm indeed produces the GCD.